In this next unit, we're going to talk about how to simplify radicals. So today we're going to start out with reviewing what we already know. So I have 6 examples here. We're just going to kind of go through them. It should all look pretty familiar. So let's start with number 1. I have the square root of 10 squared. We know the square root and square root are opposites, and they cancel each other out, so I'm just left with the number 10. The square root of 8 squared would work the same way, so I'm just left with 8. So 10 minus 8 is 2. Okay, as I move on to number 2, it looks similar, a little bit different. Since both of the numbers that are squared are underneath the radical, I'm going to square them both. So I have 100 minus 64. 100 minus 64 is 36, so I get the square root of 36. 36 is a perfect square. The square root of 36 is 6. So you could see if you compare numbers 1 and number 2, depending on how they're formatted and using your order of operations, it can affect the outcome of the answer. Okay, moving on to number 3. I actually probably should have looked at number 3 before number 1, but the square root of 9 squared is just 9. Square root and squared cancel each other out. But the reason I have it as number 3, so we can compare it to number 4. So number 4, we have the square root of 11 squared. So the square root and the square root are in opposite places, but they're still opposites. So they still cancel out. And I'm just left with the number 11. So moving on, instead of just simplifying with squared and square roots, the second part of your assignment, we're going to start talking about how to simplify radicals, something we've been doing all year. So 75, I'm going to break down the factor tree. I have 3 and 25. 25 is 5 and 5. I have a pair of 5s, so 5 goes to the outside of the radical. 3 stays on the inside. And if we want to take a look at that a little bit further, let me do it in red here, get the same answer. So I have inside my radical, I have 3 times 5 times 5. So I have a pair of 5s. And if you look at it, it's really 3 times 25, which allows me to take the square root of 25. The square root of 25 is 5. Can't take the square root of 3, so it stays where it's at. So regardless of which way you look at it, you still get 5 square roots of 3. And if I move on to number 6, same type of problem. The only difference is this 4 that's already on the outside of the radical. So I'm going to break 80 down. I know 80 is, let's use 8 and 10. 8 is 4 and 2. 4 is 2 and 2. Pair of 2s, 2 left over. Still have this 10, which is 2 and 5, which sets up another pair. And then I ultimately have a 5 left over. So now I move all the pairs to the outside of the radical. I already have a 4, so I'm just going to bring my 4 down. I have a 2, then another 2, then I have this 5 left over. 4 times 2 is 8, times 2 is 16, square roots of 5.